Welcome to my channel. My name is Chaki and today's class is going to be on calculation of support reactions. Now let us take an example of a frame. Now this is the question given. A, B, C, D is a frame. Point A is hinge support. Point B is roller support. At point C, a 60 kN load is acting vertically downward. At point B, a horizontal load is acting along the x-axis, positive x-axis. Okay, now for the solution. Step 1. We are going to calculate total external reaction, say RE. Okay. Now we are going to draw this particular frame along with the support reactions. Now we are going to assume the direction of the support reaction in this case. Okay. Point A is hinged. Okay, now BC is 3 meter, CD is 3 meter and AB is 2 meter. Now at point C, a 60 kN load is acting. This is C, this is D, it is a roller support, and A is a hinge. At point B, a horizontal 10 kN load is acting. Okay, this is 3 meter, this is also 3 meter, this is 2 meter. Now since A is a hinge support, we know that hinge support, there are two reactions. One is a horizontal and one is vertical. Okay. So we are going to write it as a vertical reaction and a horizontal reaction. HA is the horizontal reaction and RA is the vertical reaction at point A. Now for point D. Point D is a roller support, right? So there will be only one vertical reaction. Okay. There will be only one vertical reaction acting upward. In this case, we are going to consider the direction upward and RD, which is the vertical reaction acting at point D. So the total external reaction at point A, RE at A is 2, RE at D is 1. Therefore, the total external reaction of the frame is 2 plus 1, 3. Okay. Now for step 2. For step 2, we are going to compare the RE with E. Now what is E? E is the total number of static condition of equilibrium. So what is that? It is the number of external static condition of equilibrium plus the number of internal static condition of equilibrium, that is presence of a hinge. So what is the number of external static condition of equilibrium? It is 3. So we are going to write that E is equal to 3. Now what are those? Summation of Fx equal to 0, summation of Fy equal to 0, summation of mz equal to 0. Now these are called static condition of equilibrium. Now we are going to compare them. RD is equal to, as we can see, it is equal to E. RE is 3 and E is also 3 for this particular frame system. Now since there is no internal static condition of equilibrium, that is, there is no internal hinge present, so we do not need to concern ourselves with that. So RE will be 3 for this particular frame system. 3. It is, we can say that the frame is determinate. Now what is the meaning of this? Why it is determinate? When RE is equal to E, the structure is externally determinate. What does this mean? That with the help of equilibrium condition, that is summation of fx, summation of fy and summation of mz, along with internal equilibrium condition, we can find out the values of external support reaction. Okay, in this case RA, HX and RD. So if RE is greater than E, then the structure is externally indeterminate. So we don't need to find the extra equation in terms of deflection, slope or rotation, which are the compatibility equation. In this case we don't need them. Okay, because it is a determinate. Now for step 3. We are going to take the equilibrium condition, that is summation of fx equal to 0, summation of fy equal to 0 and summation of mz equal to 0. Okay, now first we are going to consider the summation of fx equal to 0. What does this mean? That the summation of all the horizontal forces acting along x direction is 0. Now since at point A, HA is along the positive x-axis, okay, we can see that HA is positive x-axis. We are going to write as HA positive. At point B, 10 kilonewton, load is also acting along the positive x-axis, so plus 10 kilonewton is equal to 0. After solution, we get that HA equal to minus 10 kilonewton. Okay, now please look at this very carefully. What does the minus sign indicate? It indicates change in direction. This means that we have considered that HA is along the positive x-axis, but that is not the case. From solution we get that it is in the opposite direction, which is along the negative x-axis. So we are going to write it as HA 10 kilonewton. We are going to give the direction like this. Okay. Now we are going to consider another equilibrium equation, which is summation of mz equal to 0. In this case, we are going to consider summation of all the moments about point D to be 0. That is, summation of all the moments acting at point D will be 0. It is a very important part for the sign convention. What is the sign convention in this case? There are two sign convention. It does not matter what sign convention I take. The first one is taking anti-clockwise as positive and clockwise as negative. The second one is taking anti-clockwise as negative and clockwise as positive. Now both are right, okay? Both are same. For our particular case, we are going to consider the clockwise as positive and anti-clockwise negative. If you are taking the upper one, that is anti-clockwise as positive and clockwise as negative, both will be same. For our convenience, we are going for the second one. Okay? Now, so I'm going to equate every moments. We can see that RA is acting along the vertical y-axis and it is 6 meter away from point D. 3 plus 3, 6. So we are going to write as RA into 6. So what will be the sign and their corresponding direction in this particular case? Let us see. Now suppose this particular metal piece to be RA. So my index finger is point D. See, it's point D. And it is 6 meter away from RA. So what will be the particular direction in this case as the force move? It will be in clockwise direction, as you can see. So it is positive. Clockwise direction, so positive. We are going to write it as positive. Now for HA, the horizontal reaction acting at point A. We know it is acting in negative x-axis, right? We have calculated its negative x-axis. Now take this particular metal strip to be HA. It is acting along negative x-axis. Okay, now this is point D. This particular string to be 2 meter, okay? Consider this particular string to be 2 meter. Now from D, it is what is the direction then? HA is acting in what direction? It is acting in clockwise direction. Let me show you clearly. It is acting in clockwise direction, as you can see. So we are going to write it as positive HA into 2 meter away from D, so 2. Now for the 60 kilonewton load, which is acting vertically downward and it is 3 meter away from point D. Similarly, from the above case, this particular metal strip to be 60 kilonewton, okay? Let me show you. And this string to be 3 meter, okay, from point D. So what will be the direction in this case? It is anti-clockwise direction. As you can see, it is going in anti-clockwise direction. So we are going to write it as negative because anti-clockwise direction is negative. So minus 60 into 3 equal to 0. Now we are going to solve this. The solution, okay? RA into 6 is equal to 60 into 3 minus HA is 10 kilonewton. So we are going to write minus 10 kilonewton into 3 into 2. RA is equal to, so let us calculate, 60 into 3 minus 10 into 2. It is 160. We have to divide it. 160 divided by 6, right? 6 equal to 26.666. Oh, okay, now we are going to take this as 26.67 kilonewton. This is upward, vertically upward. Now there is another equilibrium equation, that is summation of Fy equal to 0. Summation of all the forces acting along y direction, that is vertical direction, to be 0. Now, what are those? Let us see. RA is acting vertically at point A. Similarly, RD is acting vertically at point D. Okay? It is vertical. 60 kilonewton load is vertically downward. 60 kilonewton is vertically downward. As you can see, it is downward. So we are going to write it as RA plus RD. It is RD minus 60 is equal to 0. Now we are going to solve this. Okay? RD is equal to 60 minus RA. 60 minus 26.67. So 60 minus 26.67 is equal to 33.33 kilonewton. 33.33 kilonewton. Acting vertically upward. Okay? We are going to draw the corrected reaction for the frame. What are those? Let us draw. It is a roller. This point is hinged. This is B. A 60 kilonewton load is acting at point C. This is point C, and at 10 kilonewton at B. This is D. This is C. It is 3 meter. This is also 3 meter. This is 2 meter. And it is A, point A. Now, from the solution, we know that HA is acting along negative horizontal axis, that is, it is acting along the opposite direction of what we have considered previously. So we are going to draw like this. HA is acting along this direction, which is 10 kilonewton. Sorry, this is 10 kilonewton. Also, vertical reaction RA is acting along vertically at point A, 26.6 kilonewton. Similarly, D is acting vertically upward. RD is acting vertically upward. It is 33.33 kilonewton. Thank you.